Okay, we're trying to figure out which ones of these are functions. And all you need to look at, if it's a graph, you need to be able to do the vertical line test, which means there's no way that you're going to hit 2 points when you draw vertical lines anywhere in the graph, okay? So if I had a graph like this, so if the graph looks like this, let's say, and it's like this would not be a function because when you draw a line, you hit 2 different points. So if you can't draw a line and hit 2 points, and remember these W's go out a little, so you're never going to be able to hit 2 points. Even parabolas, all of those that are facing up and down are functions. So this is a function. This is a yes. Okay? When you have data like numbers, you've got to look for repeats in the X column. Because look at this first one here. And if you see this 1, it goes to 0 and 15. Well, when I graph 1, 0 is right here, and 115 is going to be way up here, but that's going to fail the vertical line test. So this one is not a function. The second one is pretty vanilla. There's nothing repeating on either side. When there's nothing repeating on either side, you can always say it's a function because you don't have to worry about it. And the same goes for this last one. It's a yes. But this other one down in the left-hand corner, you have 2 5s repeating and 2 4s repeating on the X column. And the 4s repeating are going to create a vertical line, and the 5s repeating are going to create a vertical line. So this would be not a function. The only one they didn't show you, which they really should have, is where the Y repeats. Where the Y repeats, it's not a problem. Because let's say you have an X, Y here, and let's say you have a 1, 0, and then you have a 2, 2. Well, if you graph that, 1, 2 is up here, and 0, 2 is up here. It does not fail the vertical line test. That's a horizontal line. So that is a function. I don't like that they didn't show you one of those in case that's on the test. Number 2, we have to decide if it's a function or not and then explain in complete sentences. So you can put some sentences together based on what I'm telling you here. You only have to worry about passing the vertical line test. And the only questionable vertical line is right here because it's going to spear that donut dot and then this dot here, right here, and right here. However, that donut means it really doesn't include that point. That is everything right to the left of that, all the way down this way. And the dot does include the point. So because this is a donut and a dot, if you would have had 2 dots there, it would have failed the vertical line test. But since this is not defined at this point, it just goes right to the left of that point, then this is a function. And you can explain it with what I just told you or ask me questions when you call me. Sorry, I didn't see the other 2 questions. I didn't draw this to scale, so you'll just have to bear with me. I put the numbers like the graph had on it, and it's saying what is the domain of the graph. Well, I'm not sure what notation she taught you. There's different notations. But if you look at the domain, you're looking at the values of x's that are included in this graph. And everything in between -2 and 0 is included here because this point here is included. And then everything all the way to 3. So there's some part of the graph over every number between -2 and 3. So your domain, and like I said, you're going to have to ask her what notation she wants you to use. But I use hard shell -2 all the way to 3, but the 3 has a soft shell. Now what the soft shell says is that it's not really defined at 3. See how there was a donut there? And the hard shell means that it included that -2 because this was a dot here. So that's your domain. It's all the values of x that have a graph on them. Now, if this graph had been broken up, you would have 2 different domains. It would like stop where it stopped and then pick up where it picked up again. So that would be the domain. The range is all the y's. So So this graph, if you were to look at the y's, that is a -2. And again, I apologize for not drawing it to scale. And it goes all the way to 20, right? But it includes the -2 because of this point right here. So your range is going to be from -2, and that would be a hard shell, all the way to 20, but the 20 would be a soft shell because it has a donut at the 20. There's no dot at the 20. But because there's this dot right here, you can say it's -2 hard shell to 20. So that would be your range. Okay, so on these two, they want you to find the domain and the range. And this is a 2 and a 4 and a -1, -2, -3. Okay, when you look at the domain, you're looking at the width of the graph. Well, that graph has 2 arrows on it, and because it has 2 arrows, it's going to keep getting wider and taller, right? So that graph on the domain is defined at -infinity to infinity. And you always use soft shells on infinity because infinity is not a number, it's a concept, so it's not really a place to stop. That's why you don't use a hard shell. So the domain, x, if you look at the width of this graph, it goes to infinity and beyond in both directions. You can go all that way. Now when you look at the range, this graph never, ever, ever goes below this line, but the arrows imply that it's going to go on forever in the up direction. So you're looking at down and up on a range. Range is the y, domain is the x. So the range is going to go from -4 included all the way to infinity, soft shell. So that's your domain and range for that one because it goes on forever. Now your domain and your range for the second one is the values of x that are included. Well, if I look at the x's here, it goes from -2. So on both of these, sorry, the recording went off. So when we're looking at the domain, it goes from the red lines are from -2 to 4, and there's a solid dot at 4 and a donut at -2 on the width. So it goes from -2 to 4, soft shell, hard shell, because it includes the 4, but it doesn't really include the -2. The same thing if you look at the green lines, that's your range. How low does it go and how high does it go? And this goes from -2 to 7, but again, the -2 is a donut, so it's a soft shell, and the 7 is a hard shell.